Alright, hi everyone, welcome back to the Odin series. So in the last episode I said that I couldn't find mutexes, but they do exist. They're just in sync, which I didn't know about. So we'll cover them now. We use exactly the same example as last time, just counting vowels, but I've added some new things. So last time we basically had just unthreaded, threaded, without a mutex, and then threaded with data. This time we'll show it with mutexes. So what I've added is unthreaded, as before, threaded as before, threaded data, but then we have mutex, RW mutex, and then atomic. So I'll show you all these. So first we go to mutex, which simply just calls here count vowels threaded mutex, which again it's exactly the same as before really. We're still using a global variable, so global vowel count. So in this we set the global vowel count to 0. And then we just go to mutex. So basically how mutexes work, we have a mutex here. We have two actually, but we're using this one mutex. It's a sync mutex. So yeah, basically we just lock it. So sync.mutex lock at mutex, and it locks it. And then we add plus equals 1, and then we unlock it. That's basically how it works. Pretty simple really. That will stop race conditions, which is basically where two threads access one thing at the same time and try to write at the same time. Sometimes it can get overwritten. Then we have RW mutex, and what an RW mutex is basically when you have a lot of reads and not as many writes. So it can be faster when you just want to read it. So it won't lock it when it's reading. Basically how it works, and it's almost exactly the same, except we use an RW mutex. And here we just say RW mutex lock and RW mutex unlock. Otherwise, it's exactly the same. And then we have atomic. So what the hell is atomic? So atomic, it's basically so what a mutex is it's basically a lock in the software, or I'm not sure if it works in the operating system level, or if it's in the software somewhere. Basically, the program itself will detect if a bool is yes or no. If it isn't, then it will wait, or it will lock the thread, or something like this. It basically is a software level. But atomic is at the CPU level. So when you change a use an instruction on a CPU instruction, it will lock it, do the instruction, and then unlock it, and it's just faster on the CPU level rather than the software level. So generally, this is probably the fastest, but it only works with really, really simple calculations. So here we're just adding 1, or we're adding something, add, subtract, and operations. It works for things like this. I don't think you can do really, really advanced stuff with atomic. It's mostly just simple arithmetic and things like that. But here I'll just run this all. So we're just going to run literally all of them, and it will just show the results. All right, so the results, yeah, unthreaded again is the fastest, because this is not a very CPU intensive thing to do. You only really need to do threading when, one, it's very, very CPU intensive and takes a lot of effort, and you can do it not sequentially. Or you need to be threaded, like if you're waiting for a response from a server, or you want to have a UI and you want the UI to actually work while you're waiting for something. That's the general reasons to use threading. This situation is not a good one, it's just an example to show how to do it. So here in the threaded one, we didn't actually get a race condition. We sometimes do, sometimes don't. I can show you that. Sometimes you get a race condition, sometimes you don't. It's just random. And it's not giving me one, so I don't care. Anyway. But if you look here, yeah, I mean, that's a lot slower. Yeah, anyway. Maybe this is just random. It seems to be random. Like sometimes it's really slow and sometimes it's not. Anyway, so threaded is very slow. And it's not the way to do it because you can get race conditions. And anyway, then we have threaded mutex, which for some reason, like sometimes the threaded mutex is faster, sometimes it's slower. But in this situation, it doesn't really matter because I'm not really reading a lot. I'm only writing. So it's margin of error. It just seems they're both it depends. And then atomic is actually slower in this example, but generally it's normally faster. I don't know. It seems to be a bit random. Like there's a margin of error going on here a bit. But generally the atomic is faster than the other two. And then data is faster because we're not having a mutex and they're independent. because how I worked before is the data one. Basically, it creates a slice of integers, and then it passes the slice to the data, which is basically a pointer, I believe. It's like a slice of so data is just a pointer in threading in thread. Yeah, so if you wanted to like just find anything in Odin, the best way to do it is not actually to look at the folder. It's best to just type stuff in on packages. So let's go home, packages, and then just type stuff in. So you can type in thread, for example, and then you can find here thread.thread, and then we have data raw pointer, which basically just means it points to anything. It could be anything. It doesn't matter. Like, it's basically just generic. So we basically just have a pointer to part of the array by the index. So we don't need to lock it now because it's just independent. It's just independent, which is the fastest in this situation. But the approach you want to use depends on circumstances, what your goal is, how simple you want it to be. Sometimes it's a bit more complicated to send, a raw pointer, and then you also have to convert the raw pointer. So yeah, last time I didn't really understand why we had to convert this. But if we look at transmute, the transmute operator, so the transmute operator is a bit cast conversion between two types of the same size. So if something is the same size, you want to convert it, use transmute. And here we have a raw pointer, which, what is it? It could be anything. We don't know. It's just bits, basically. And we have to convert it to the type we want to be able to use it. Otherwise, Odin doesn't know what it is. So here we transmute it into it's a pointer to an int. That's what we do. So it's a pointer to an int. We cast it to that. That's basically it. Transmute just turns whatever data as a raw pointer. We're turning the raw pointer into a pointer to an integer. That's what transmute does, which I didn't really understand at the time. Now I kind of understand it. Anyway, so it depends what your approach, what you need, what you're doing. So mutex is the slowest. It locks reads and writes at the same time. The read-write mutex will lock writing, but it's good when you have lots of reads. So if you don't want to lock the thread when you want to read it, it's good for that. Atomic will lock it at the CPU level, which is generally faster, but it can only do simpler calculations. And then using data is probably the fastest, but also the most complicated because you have to make a slice. It depends what you're doing. You don't necessarily have to, but it has to be a pointer to something. And you have to transmute it, so it's a bit more complicated. Anyway, so that hopefully is... I'm not sure, there's probably more things about threading. I'm not really an expert in threading because it's probably the most complicated thing in computing, honestly, in programming. But anyway, let me know if you have any questions or suggestions. See you guys next time.